Hi, welcome to this tutorial in which I'm going to look at the rule of division or the law of division. This will be part 1 and part 2 will be some questions for you to try. Let's consider this problem, 32 divided by 8, which we know is 4. 32 can be written in base 2 or as a power of 2. 2 to what power? How many 2's do we multiply by themselves to get 32? Well, the answer is 5. And the 8 is 2 cubed. But we know that 4 is 2 squared. So what observations can we make about the powers or the exponents going from those two to get this answer here? Well, 5 minus 3 is 2. So it would seem that we subtract the powers if the base is the same when we're dividing. Well, let's have a look at another example. Suppose it's a to the power of 5 divided by a squared. If we write this out in full, a to the power of 5 is a times a times a. How many times? Well, the answer is 5 times. And a squared is a times a. We can cancel this a without a and this one with this one. And what's left in the numerator? A times a times a is a cubed. In the denominator, 1 times 1 is 1. If you divide anything by 1, you get the thing itself. So a cubed divided by 1 is a cubed. You must write a cubed, not a cubed divided by 1 for an answer. It must be in the simplest form. So does the rule work? 5 take away 2, do we get 3? Well, the answer is yes, we do. So we can now generalize this and say if we have x to the power of m divided by x to the power of n, the answer should be x to the power of m minus n. And this is the rule of division or the law of division. If the base is the same when you divide, you subtract the powers, the top power, and so the power in the numerator minus the power in the denominator. Okay, so for example, y to the power of 8 divided by y to the power of 3. What do we expect the answer to be? Y to the power of 8 minus 3, which is 5. Let's write it the other way around, y cubed over y to the power of 8. What would the answer be? Well, it would be a negative answer. 3 minus 8 is negative 5. Okay? Suppose we had y to the minus 2 divided by y to the minus 3. Well, it would be y to the top power, the power in the numerator, take away the power in the denominator. And these two negatives make a positive. So what's the final answer? Negative 2 plus 3 is 1. So the power is 1, we don't bother to write the 1 in. Okay? Now, let's bring in some numbers in. Suppose we have 2c to the power of 7, d to the power of 5, divided by, say, 6 c squared d. What does 1 do? Well, we can cancel the 2 goes into 2 once, 2 goes into 6 3 times. So we're going to get a third in it. Okay? And c to the power of 7 divided by c squared is c to the power of 5. 7 minus 2. And d to the power of 5 divided by d to the power of 1 is d to the power of 4. So we could still write this if we wanted to as c to the power of 5, d to the power of 4 all over 3. Those people who often write slanting fractions, and I'm talking about the third, if you put the c to the 5 and d to the power of 4 at the same level as the 3, that's incorrect mathematically. So try and avoid slanting fractions if you can. Now, if we write this out in full, it will be 2 times c times c times c times c times c times c, 1, 2, 3, 4, 5, 6, 7 of them. And the d's, there will be 5 of them. Okay? Divided by 6 times c times c times d. If we now do some cancelling, we can see that one of the d's there will cancel, so there will be 4 left there, which is d to the power of 4, and that c would cancel with that, this one will cancel with that. We left with 1, 2, 3, 4, 5 of them, which is c to the power of 5, and the 2 will go into 2 ones, into 6, 3, so you get the 3 at the bottom. 3 times 1 times 1 times 1 is the 3. So it works. Okay? Okay, next example. What happens if you have something like 2c cubed divided by, say, 4c to the power of 4? Well, the 2 and the 4 will cancel to leave you a 2 at the bottom, and the c cubed divided by c to the power of 4, so we've got a half. C to the 3 minus 4 is negative 1. That's one way to write the answer. You could write it as c to the minus 1 over 2 if you wish. But let's have a look at the same question again and write it differently. 2 times c times c times c divided by 4 times c times c times c times c. And let's do some cancelling. There's a half coming out of that. This c will cancel, this c will cancel, and that c will cancel. So you can see that in the numerator it's 1 multiplied by itself 4 times is 1. In the denominator, 2 times 1 times 1 times 1 is 2, and there's 1c on its own. So this is an altered answer to that one. They're both equivalent. They're equal to each other. Okay? So, what happens if you divide 8 by 8? Well, the answer is obviously 1, but 8 is 2 cubed, and that 8 at the bottom is also 2 cubed. Subtract the powers, you get 2 to the power of 0. So what's the observation then, or conclusion, is that 2 to the power of 0 is equal to 1. Is that always the case? Anything raised to the power of 0 is 1? The answer is yes. X to the m divided by x to the m, assuming x is not 0. If you divide anything by itself, what would you get? You'd get 1. And if you subtract the powers, m minus m is 0. So here's another nice important item to remember, that any number or any letter raised to the power of 0 is 1. You can try that on your calculator and you'll see it's correct. Okay, to finish off with, we will be coming across that 0 exponent later on. So what about y over y squared? Well, it's y over y times y, which is 1 over y, because that y cancels with that one. Can you see that? You get 1 over y times 1, which is y. But if we use the rules of indices, the division rule, we'll get y to the 1 minus 2, which is negative 1. So we're saying that y to the negative 1 is the same as 1 over y. This will come up later on when we do negative indices. Okay? Just one last example. A cubed y squared over a y cubed. 3 minus 1 is 2. 2 minus 3 for the y is negative 1. The alternative answer is a squared over y. Have a think about why it is. Until the next one, thank you for listening. I hope you found it useful. Take care.